Welcome to the Netfim's SDI webinar. My name is Eli Merkel, Netfim's Global Training Manager. It's really great to have all of you here. We have many people from all around the world. So good morning, good afternoon, good evening, even good night for some of you. We really appreciate that you took the time to join us to this webinar. I hope you find it beneficial. Subsurface drip irrigation, which we refer as SDI, allows grain farmers to reach high and consistent yields even with limited water resources. SDI can fit any plot, shape, or size and any topography or soil type. Whether you grow rain-fed or have an inefficient irrigation system you are considering replacing, so this webinar is for you. In the upcoming hour, we have the pleasure to host one of the world's top experts in SDI, Dr. Rami Gibbs, Head of Agronomy Research in Nטפים, and Mr. Ross Roberts, one of the most experienced designers and installers of SDI in the world, and the founder and owner of Diversity D. As some of you probably notice, you can contact us using the Q&A panel. Please feel free to do it. We're monitoring it all the time, all along the webinar. Our experts will answer you and try to answer you during the webinar, and we'll try to refer to each and any question that will rise. Additional point is that this webinar is part of a series of webinars Nטפים is conducting. It is being recorded and will be available as the rest of the webinars in our YouTube channel. In a short while, we'll share with you the link to this channel. What else? Okay, I think that's about it. Again, feel free to contact us using the Q&A panel. Before moving forward, we would like you to share with us a little bit information using a quick and short poll. So can we upload the poll, please? Okay, so one question is, what crops do you grow? Let us know. Please share with us. You should see the question now appearing on the screen. Okay, so which of the ones that here do you grow? Simply, mark it and click submit. Okay, I guess we're getting answers coming. Okay, let's wait several seconds to have some more answers. Guys here, let me know when you feel there are some answers. There's enough answers to share. Anyway, what crops do you grow? Corn, soybeans, other beans, cotton, rice. Okay, I think we're getting some answers, right? Accumulated. And we can share with you all the answers in a few seconds. Okay. So let's see the results. Okay. So I see many of you answered corn and soybeans, and I see some of you answered wheat. And the rest is spread between the other answers. Amazing, great. Okay, and one more short poll, and then we can move forward. So, guys, can we upload the next poll? Okay, so the question is, what is your current main irrigation method? Okay, what is your current main irrigation method? Once again, please mark the most relevant one, and click submit, and we'll share with you the answers in a few seconds. We'll just give a chance to everyone to answer. Let's see. So what is your current main irrigation method? Rain-fed, flood irrigation, rain gun, pivots, or drip irrigation? Okay, so I think we're getting some answers arriving already. We'll give like 5-6 more seconds to everyone a chance to answer. Let's see. very interesting for us, by the way. Okay, so do we have some answers? Okay, so let's see, and we'll share with you the results. So nice. Okay, so about 42% answered drip irrigation. Some of you answered rain-fed and pivots, and the rest using a small amount of you using rain gun and flood irrigation. Amazing. Okay, so thank you very much for sharing and cooperating. And with no further delay, Ami, the stage is yours.
Hi, everybody. Like Eli was mentioning before, we are going to speak about surface drip irrigation, especially for growing crops. And I'm starting, and then Ross will continue with his actual and practice knowledge, much more than me. So, what is SDI? Actually, SDI is drip irrigation that is buried and is supposed to apply water and nutrients straight to the roots of the plant. Well, when we are speaking about SDI, we distinguish between shallow, medium, and deep installation. When you're speaking about shallow, it can be about until 0.1 meters. And you can see also the numbers on inches. I'm not going to repeat it. Normally, it can be on corn when people are using the system for one season. They install it and retrieve it in the end of the season. So they put it on a shallow bearing, especially when there is high wind condition, in order that the lateral will stay on one place. Medium installation is 0.10 to 0.25 meters, and the deep installation is 0.25 to 0.4, especially in location when we need to do cultivation with power plow or chisel, and we need to go to 25 or sometimes 30 centimeters. So over there, we need to put the laterals below the tillage operation. Otherwise, we are going to affect the drip irrigation. Okay, so when we use SDI, or when is reasonable to use SDI? When it's long-term landowner ownership for long-term investment, because you want to use the drip irrigation for a large time scale. The second is large-scale growers and project. Less labor cost than on-surface drip irrigation, less labor cost when you compare it to overhead irrigation, maintenance of sprinkler or center pivot irrigation. You possess the SDI, and if you treat it well during or outside of the growing season, then you don't have to do too much during the growing season. Then areas with high labor cost, after the installation, you don't need to deal too much with SDI. So you don't need actually any labor. Shortage of labor, you don't have manpower, the same principles. SDI doesn't need too much labor. Zero minimum tillage doesn't damage the drip. Yes, it doesn't damage the drip in one end, but in other end, we are speaking about compaction, not on because of the tillage, but especially because of the harvesting machine, tractors, and trucks. We need to pay attention for it. There is solution for it. I'm not going to deal with it, but it's existing and we need to pay attention to it. The other item is shortage of water. When we compare it to surface drip irrigation, we can avoid or we can save something like 15% of the water consumption. When you compare it to flood irrigation or even to furrow irrigation, these percentages are moving up. We are speaking about 30, sometimes 40%. When we are speaking about center pivot, more or less, we are speaking about the same 15% like surface drip irrigation. And insurance cost. Center pivot, you need to pay high insurance cost. When you're speaking about SDI, is less, it's less expensive. Okay, so what are the advantages? When we're speaking about agriculture advantage, it's keeping the surface area dry, meaning that because of this, we got less wheat population, and it's meaning that we need to use less herbicide compared to some other methods. On the same spot, we're speaking about danger of root neck disease. They are decreasing to a large extent because you don't create moisture condition in this zone. Reduce soil compaction, less tillage, prevent surface runoff, especially in soils that got high sodium concentration or heavy soil with low infiltration rate. And we can short the time between crop cycle and increase the yield. We can take as example the alfalfa. In alfalfa, the cutting between stopping the irrigation before cutting and afterwards starting the irrigation again with the SDI, we can shorten this period, meaning that we can add another cutting at least, and by this to increase the yield. We improve fertilization efficiency, especially when you're speaking about phosphorus, because phosphorus doesn't move in the soil. If you apply phosphorus with surface irrigation, like center pivot, it concentrates on the top soil surface. It doesn't move to the root side. With the drip, we deliver the phosphorus straight where the roots are, increasing the efficiency to a large extent, and improving or increasing the water use efficiency because the evaporation part is reducing to minimum.
We're not running
ecological advantage.
Anyway. Yeah,
Ross, we can hear you. When we are speaking about ecological advantage, we're speaking about using, for example, recycling water. In Israel, about 70% or 75% of the water that is used for irrigation is coming from recycling water. I can't say that everything is with SDI, but there are some with SDI and the rest of them with surface drip irrigation. It's avoiding all kinds of dispersion of all kinds of unnice things through the water when you are using sprinkler irrigation. And in another end, when we are speaking about recycling water, normally we got some nutrients in the recycling water, so we can reduce the quantity of the nutrients and the total quantity of fertilizer that we need to add. Reduce the need for herbicide, because then we are not wetting the soil surface. Reduce the fertilized quantities because the lateral, in most of the cases, is located close to the root system. So it's very efficient for the nutrients to be absorbed by the roots of the plant. Reduces carbon dioxide emission to a large extent and reduces evaporation, and by this saving water. When we are speaking about improvement, we can enter to the plot whenever we want for sowing, harvesting, spraying. SDI can function on the same time that we are spraying, no interference. Excellent from our point of view. And extend the irrigation system work life. When we are speaking about this in Colby, Kansas, we are speaking about drip irrigation, SDI, drip irrigation that is working for more than 20 years. Extraordinary. I don't see too many irrigation systems that got this ability. Okay, let's move to, to technical advantage. Technical advantage, reduce mechanical damage to the irrigation system, prevent damage by animals and thieves. You don't see the irrigation system. Reduce manpower cost. We spoke about it. You possess it 1 year and that's it. You don't deal with it. It's already was speaking about it before, so I'm moving to the other item. What's going on? Okay. Commercial advantage, reduces manpower cost, reduces energy cost. Less tractors, less pump, less herbicide and fertilizers, eliminate cultivation. I wouldn't say eliminate, but we can reduce the cultivation to minimum. On the other hand, we increase profitability, extend the irrigation system work life, like I mentioned before. Okay, what different field crops we can grow with SDI? So over here, we are speaking about cotton, sugarcane, alfalfa, corn, soybean, sunflower. There are some kind of field crops or vegetable like potatoes that we shall do shallow bearing, or processing tomato when we can bury the drip to something like 25 or 30 centimeters. But we are going to focus on these specific 6 crops. When we are speaking about sugarcane, the distance between the lateral. First of all, we are speaking about one lateral between 2 rows. The distance can be between 1.5 to 2.4 meters. Normally, we're speaking about 1.8 in general. Injection depth normally is medium, between 0.15 to 0.25 meters. And the dripper lines spacing is between 0.4 to 0.6 meters. The next candidate will be corn. More or less the same idea like the sugarcane. We're speaking about one lateral between 2 rows. Distance between laterals 1.8 meters. Injection can be shallow, something like a few centimeters only to cover the lateral. Medium, something like between 0.1 to 0.25 meters. And deep, 25 to 40, especially when we are dealing in heavy soil, cold places, rain, heavy rain, and you want to get to open the soil in the fall time in order to let the air penetrate and get rid of residues and create a better condition from drainage point of view. In this case, we need to bury it deep, otherwise we are going to affect, or we are going to injure the drip irrigation. Drip line spacing, again, is 0.4 to 0.6 meters. Soybean, parallel to corn, normally it's in rotation, so the same principles that are working for the corn catch up also for the soybean. Cotton, up to 1 meter in general. Injection depth, normally we're speaking about deep. Dripper line spacing, 0.4 to 0.5. Alfalfa, again, 1 meter. In some sandy, very sandy soil, we shall reduce the distance to 0.8 meter. Injection depth will be medium to deep. Spacing, 0.4, 0.5 meters. This is the idea. And if we're speaking about rotational crop, normally we determine the distance between the lateral according to the lowest crop requirement. And if we are speaking about corn, alfalfa, wheat, normally we shall put it on one meter distance. Injection depth will be normally medium to deep, and dripper line spacing is between 0.5 to 0.4 meter. Okay, so we got some kind of introduction about SDI and the different uses in different field crops. I think that one of the items that we are not dealing with them too much and can create some problems after the installation, and in order to avoid it, we need to make sure that we are familiar with them, is what agronomic data we need for design and installation. So, first of all, I would like to have some historical climate data. Well, when I refer to historical climate data, I speak about minimum and maximum temperature. We're speaking about wind, velocity, and direction. We're speaking about radiation. And from these items, I can get the evapotranspiration, the reference evapotranspiration, or in short, ETO. And I would like to have some estimation of the rain quantities. I know that the rain distribution is different from one season to the other, but if I got on average the rain quantity, it's a part of the total water budget that I'm going to use during the growing season. Now, if I can get it on a daily basis, it's excellent. I'm familiar with this, that in many places, we don't have the daily data. So even if you get the weekly basis of 7 to 10 years, it's good, because then we can use the data and to estimate, and we can estimate the water consumption or the peak water consumption during the growing season, and how we are going to do the hydraulic design. Why 7, 10 years? If 5, 6 years ago, we were speaking about 15 to 30 years, we are familiar with the trend that climate is getting warmer, or it's not only getting warmer, it's unstable climate. So we are going to a shorter zone. So 7 to 10 years is fine from our point of view. Now, after I am getting the data about the climate, I want to know what crops were before. It's interesting, for example, if I know what kind of herbicide they were using in different locations in order to make sure that I'm not going to put sensitive crops on the next few years. But I want to know for the design, what are the crops that are going to be in the plot rotation? What are the target yield on the different crops? What is the root system character? When I'm seeding or planting, and when I'm expecting to have the harvesting time. Then what is the plot topography? Then after I'm getting data about climate, crops, I want to know what soil I got. If I got historical soil survey, it's excellent. If not, I need to figure out how I can get data, or I can create data about what I'm getting on the plot. The other item that is very crucial is the water source, is the capacity. How much water I got in different months during the growing season. And what is the water quality? And the water quality is not only from chemical or chemic water quality, but also the physical water quality, because I can use it, one, to understand what kind of irrigation system I'm going to put, like what kind of filters. If I got high organic load, if I got ice suspended solid, I need to understand it in order to design the best solution for a certain problem that I got with the water. The other end, if the water got nutrients or the water got high electric conductivity, I need to be aware to this. Because if it's got high electric conductivity, I need to know how much extra water I need to add beside the water consumption of the plot, of the crop. So this is why I need the water quality. And the last one, and maybe there is more, but the plot drainage and the groundwater depth during the year. Because we can put SDI and find out that the drainage is terrible. And then we are not going to get what we expect from this plot and from the big investment of money. And in the end, our target as dealers, any irrigation company, is that the farmer that is going to buy the equipment will gain more money in the end of the year. This is our target, because if you're getting more money, there is a good chance the next year you're going to extend the area that you irrigated with SDI. So we need to make sure that everything will be, how I said, that when we are going to design, we should be aware to all the data that exist. Okay, so we spoke about historical climate data, average of 7-10 years. Over here you see temperature, mean rainfall, solar radiation. The data exists. We need to, not everybody can reach the data. I understand it. But let's say over here in the United States, Kansas, Manhattan, Kansas University, they collect daily data about the different climate parameters, and they got historical data. So I need only to click on the spot, on the circle, on the location that I want the data, and I'm getting the data. Some of the data is with the agriculture department of the state, or with extension office, university. Some is in airport when they collect some meteorological data that consists of wind velocity and direction, temperature, maybe humidity, etc. So we can collect data for different locations. And the guy that doesn't have ability to get the data, he can ask us, because we got option to get the data from different resources. Only ask, this is what we are looking, or this is what we are asking. Okay, topography. There is long-term influence and there is short-term influence. Long-term influence when there is uphill and downhill. The uphill when is more exposed to erosion by wind or by water. Over there, the soil layer or the soil profile is going to be shallower than what we expect to see on the downhill location. So we need to look on them on two different plots, that the water demand and the irrigation interval is going to be different. It's not going to be the same. The other issue is the sun ray angle that reach the soil surface. If it's southern, northern, again, it's a completely different picture from the point of view of water consumption. We need to pay attention to it. And it's not too complicated to do it. So, what is the purpose of soil survey? And I'm going to speak a little bit about soil survey because from my point of view, it's a crucial issue that in many places we don't pay too much attention for. So the purpose of the soil survey is to get data about the physical and chemical properties of the soil profile. Identify variability within the plot for definition of management zone. There are a few options for soil survey application. First of all, you're reaching the farmer, and I'm sure that Rose can tell you a lot about it. You're reaching the farmer, ask the farmer, listen, guy, where is the most fertile area? Where you're getting more yield? Where you think that you got a light soil, heavy soil, medium soil, all kinds of things. A guy with experience of 20, 30 years will show you exactly where are the different soil types within his plot. This is one option, and sometimes it's not a bad option. The other option is to look on historical soil survey. There are historical soil survey that was done years ago that are sitting on different places, even in the internet. We need only to look for them and to get them. If we don't get, we are coming to a farmer that is a young guy that doesn't have any real agriculture experience. I don't know, he's coming from the city, he wants to change his way of life. He doesn't understand about what is soil survey, what the plot looks like. Then if you don't find anything historical, you need to do some kind of a soil survey. So the green cell option, and I will going to discuss it in a few minutes. This is the first option. It's a nice option, but demand a lot of manpower, many samples, labor, money. So if we want to reduce the quantity of labor, money, but still to get good understanding about the variability on the plot, there is a methodology that we can call it management zones. We can define management zone according to electric conductivity measurement or previous yield maps or Google Earth map or satellite imagery that indicate previous crop coverage. For example, if you see that outside of the growing season, there are green spots of width. It can give you indication of a shallow water level or water table level or problem with drainage. And you can look, and if it's coming year after year, then you understand that you got a problem over there. So once you identified the different variability, you can perform a soil survey and sampling each one of them according to the marked zones. Now, if the field is expected to be uniform, and sometimes it's happening, select a location in the field that is expected to best represent the soil texture. It won't be the edges of the plot. It's going to be where it's the middle of the plot. And then one sample is every 15 hectares. And it's not bad. Why? Because the other option, when we're speaking about green option, and this is the grid option, you can see you need to dig, and each point represent one area of that you take something like a few 5 to 6 sub-samples, integrate them together to one sample. You need that over here you got plenty of location to sample. Like I mentioned before, cost, labor, not nice. So compared to the 15 hectare that I mentioned before, over here, and if we are speaking about Illinois recommendation, they're speaking about it every 2.5 acre. So 2.5 acre or 15 hectares, I assume that most of you would like to go for the option for the 15 hectares. So this is when you don't have too much knowledge about what's going on the field or on the plot level. But if you using another options like measuring the electric conductivity of the soil, and you can do it manually when you're speaking about small plot, or you can do it with tractor or with a wagon or with some other machine. You're speaking about big plot. It gives you a rough estimation of the variability within the soil. And for example, this is a survey that was measuring the electric conductivity to define where there is a salty spot and to understand why these salty spots were developed in the first place. So over here you can see the scale that the light blue area, green area are low salinity. And then when you are moving to the dark blue, like over here, or when we are moving to yellow, white one, then the salinity is increasing. So from my point of view as a farmer, when I'm getting this map, I know that this area I'm not going to cultivate it, this area I'm not going to cultivate it, and this area I'm not going to cultivate it, because why to waste money? If I want to get the best results, this is the location that I'm going to deal with. And if I want to increase the area, and then I need to take care of the yellow spots over it to understand why they are getting a little bit salty. So this gives you indication where are the problems, and if you want to deal with the problems and everything, you know, it's cost and benefit, yes or no. Another option, guys are collecting yield maps. And a normal farmer in South America or in North America, when he's working on large scale plot, want to know how much he's harvesting from each location of the plot. So what he was doing over here, we took 6 ears of corn, 2 ears of soybean, then normalized the yield. You don't need to make all of them on the same platform that we can compare apple to apple and not apple to whatever. And then again, it's interesting because we see a picture, and the green represent high yield, the yellow represent that the yield was decreasing, the red represent location with a very low yield. Now, if we got this map first of all, we understand that we can sample the green separately, yellow separately, red separately, and if we got some kind like orange, we can take from the orange one also. And we can define why we got the differences from the point of view of the yield. Is it because we got lousy drainage, or we got salty area, or the organic matter is different in the different location? It gives you indication of the problem. And the first item from our point of view is understand the problem in order to bring the solution. And we can get it. Only to look on historical data, not to complicate. And in the end, what we are getting location with the same color that actually represent the same soil character. And from each color, we can take soil sample. And you can see it over here, for example, that each color represents different soil character. This is from the green area, this is one from the blue area, and this is from the orange area. The color of the soil look different, the properties, the physical properties and the chemical properties can be different, and from our point of view, it's crucial that we should know it from advance. Okay, now we got the management, each management zone or each different color. What we are doing, we are taking a pit by method, it's a shovel, or it can be by excavator, depends what we do there. And then if we're looking on the left, we can see that we can distinguish on 3 soil layers that are not the same. So the guy is measuring the depth or is measuring the length of each one of the soil layers. He's taking soil layer samples from each one of them, and he's describing the color, describing the soil particles arrangement. A guy that deals with it knows what to do. And from each layer, we take sample and we send it to the laboratory. In the right option, we see that the soil character is more or less the same. So instead of dividing according to the color, we simply scale it according to 0 to 30 centimeter, 30 to 60, 60 to 90, etc. on. We are not expecting to get too much different physical properties like texture, but maybe from the chemical point of view, maybe because of salinity or accumulation of different nutrients in different soil layers, we can get some estimation. It's from our point of view, it's important. Okay, another option that you don't want to dig is to take a drill and simply start to drill. And then when you're doing this with a drill, you are taking 15, 0 to 15, 15 to 30, 30 to 45, etc. on. The problem is that if there is a thin, impermeable layer, you can miss it because you won't see it when you do it with a drill. And it's going to affect afterwards the performance of your irrigation system. Take it into consideration. Another item you can see over here, 2 laterals. This is cornfield. First of all, during the growing season, it's not connected straight. It's connected. We irrigate requirement or the irrigation pattern. So we flag the location of the laterals and we put soil moisture sensors over here because we assume, and I think it's a good assumption, that on 2/3 of the growing season, when speaking about corn, most of the water and the nutrients will come from the drip irrigation. So the roots are going to locate close to where the lateral is. So if I'm possessing soil moisture sensor over here, it's going to give me a good estimation of the water status in the soil. And the other item is that if I want to also to get some understanding about the nutrition during the growing season, how much valuable nutrients we got in the soil, the same, I will take the soil samples from this area and send it to the lab together with leaf analysis, and then I'm getting the full picture. Sorry. Okay, next. So in the end, when we are doing all the sampling and the soil survey and everything, what is the purpose? So like I mentioned before, one of the items is to get understanding of the chemistry of the soil, nutrients, especially nutrients, okay? Nutrients availability, salinity problem. But we're speaking about the physical properties. The physical properties, I'm speaking about soil texture. What is soil texture? Is when I'm taking soil sample and I'm taking it to the lab, they separate it to the different soil according to the size of the soil particle. The smaller the soil particle is, the higher surface area that it got. So the smallest one are clay particle, that is something like smaller than 0.002 millimeters. And there is the other one that is silt, that is between this one and 0.05 millimeters. And the large one, it's the sand particles that are also, you can define them as small and big particles. Why it's important? Because according to the different contribution of each segment of clay, silt, and sand, we can define the soil texture. Yes, it's influenced also by all kinds of processes that are happening on the field, but it's giving you good estimation of what kind of texture you are dealing with. And why it's important? Because first of all, it's give you indication of the porosity, and porosity can give you indication of the water retention in the field, but it's also give you indication of the saturated hydraulic conductivity. What is the saturated hydraulic conductivity? Is how the water, how easy for the water to move on the soil profile. And when you got high number like sand, because in sand we are speaking about big diameter pores, then the water can go much more easy with less investment of energy. When we are moving to clay, see the difference. We are moving from 63 to 0.461. It's completely different scenario. And we need to be aware to this. Now, when we're speaking about SDI, you need to remember we're speaking about different, it's not different, but most of the water movement is by capillary movement. It's not by gravity. Well, I will try to move quickly, okay? So the smaller the radii, the higher the water capillary movement. So you can say in sand, the water, the capillary rise will be quick, but to small distance. Clay loam, it will be slowly, but to a large distance. And why it's important? Because it's important because when we got two soil layers, that there is a big difference on the hydraulic, the saturated hydraulic conductivity, and we possess the dripper on the wrong location, the water are not going to move to the root system. For example, if we are going to put the lateral over here, because of tillage, deep tillage, then the water will stay in this layer. It's not going to move over here. And if we got another example that doesn't represent different soil types, but if you're speaking about shallow water table, again, if you possess SDI in shallow water table, and especially if this water table is saline water, you can create tremendous damage. So you need to know what soil layers you got in the soil profile. You need to know where is the water table located on different location in places where it's shallow water table, because according to this, first of all, you determine if you can put SDI, and the second, where to put it and how to do the irrigation scheduling. So after we got the result of the soil survey, fitting then suitable for SDI, when we got soil texture that is not the same, and because of tillage we need to do it deep, we need to tell to the farmer, or you change the tillage option, or this field is not fitting SDI. This is example, possess it over here. The water are not going to reach the root zone. In this case, you need to put it the lateral over here on these soil layers and not on these soil layers. This can give you some estimation about tillage practice by drip line insertion depth. No till or minimum tillage, when we're speaking about tillage, maximum till is 0.15 or 16 inches. It's good to have GPS and RTK. I need to continue or not? It's good to have, and then the recommended drip. Recommended drip line depth will be 0.25 meters. Strip tillage is between 0.15 to 0.25. Then I will go to 0.25, 0.35. I always need to maintain at least something like 10 centimeters between tillage and the lateral depth in order to avoid any damage to the dripper. And over here you can see when we are moving to deep tillage, sometimes SDI, it's not the best solution. Okay, next. I will jump about it. You're going to get the presentation and everything is over there. Okay, so after we determine the location of the SDI, the next item is to define, first of all, what is the capacity of the soil from water retention, and different soil got different water holding capacity. Over here you got it in inch for feet, and you got it also in millimeter for 0.3 meters. So you got how much available water you got in each location. Then you need to determine where is the root, where the plant is absorbing the water. And we know that for about 90% of the plants, most of the water consumption is coming from 0 to 60 centimeters. So we need to be aware we should provide most of the water to this depth. And from the depth and from the soil character and from the lateral possession, we can define how much volume we are using in 1 hectare or in 1 acre. And this can give us indication what will be the irrigation interval between one irrigation to the other. Okay, and then the other item that we need to define is the crop coefficient. We are getting the KC, that the KC is according to the phenological stage of each crop, that in the beginning, the KC or the crop coefficient will be very low. Normally, when we design when we design the hydraulic system, we are looking on the peak demand, and this is the peak demand when it's using a lot of water on a daily basis. We are measuring the ETO. We are multiplying the ETO. That can be either from a pen or from equation, the Penman-Montagnier equation. We multiply the ETO that we are getting from the climate, data, we multiply it by the KC of the crop, and we are getting actually the crop consumption, the real crop consumption. And then, from our point of view, in order to design the irrigation system to stand for the peak demand, let's say if we're speaking about corn in the United States, the peak demand will be in the end of June, during July. It can be different on different locations. It can be 0.25, 0.3 inches, or can go also to 7 to 8 millimeters. We create a certain water table that is based on historical data, and we know for advance how much water we need to apply to each hectare of corn, soybean, or whatever, and according to this, we can calculate actually how much acre or how much hectare we can cultivate in a specific growing season. I will cut it, but only I know that the plots normally are not based only on one crop. If we're speaking about 150 hectares, some of this 90 hectares is going to be maize, some of them is going to be cotton, part of it is going to be wheat and balsam, and we actually can calculate on a monthly basis the water consumption that needed for all the plot, and according to this to do the design or the hydraulic design of the irrigation system. And give you indication if you got, according to the size area by hectares, the daily water consumption, what is the required well flow, or how much water you need to pump from a spring, a river, or whatever. So all of this data you can collect before you're putting one latte on the field level. And then if you are doing accurate, if you're dealing with the data in an accurate way, you can eliminate a lot of the problem that can be afterwards if we are not doing this correctly. The other items that is referring to nutrition is the same principle. For each crop, we know how much nutrients it needs on different phenological stages. For example, you can see it over here. Potassium in corn, you can put as a base, because after, when it's reaching VT, actually is consume most of the potassium. Nitrogen and phosphorus is consuming almost until maturity, so you can deliver it by fertigation. And the principle behind it is that we are not because we are putting SDI, we are going to put all the fertilizer through the SDI. This is not our intention. Our intention is how to use the nutrients on the best way from economic point of view and still getting the high yield. So if I'm speaking about nitrogen, I can put some of the nitrogen on the fall time or early in the spring. I can put it or start it when I'm seedling. Then I can put it on the side dress. And when I'm speaking about nitrogen, it can be also phosphorus, it can be also zinc and some other nutrients. And during the season, when the roots are reaching SDI according to where I locate the SDI and what depth, then I'm starting to use the SDI for nutrients application. Only then. So it's a combination on different methods, like I said before, in order to get the maximum profit. And I think that with this item, I will finish and I will deliver the presentation for Ross.
Okay, thank you so much, Ami. Just before moving to Ross, just a quick reference to many people that asked if you want to contact us, please do it through your local representation. You can find more information at our website, nטפים.com. Feel free to contact us through there. Ami, once again, thank you so much. And Ross, now to you.
Okay.
I'm Ross Roberts with Diversity D, and I've got to get my papers right. So we're an irrigation company. We've been in business since 1994. We are customer focused. We think if we can make our customers successful, that we'll be successful. I don't know what to do, but I've got some feedback here. Ellie, can you hear me?
Yes, I can hear you well. Just give
Okay.
it another try.
No, I'm good. I just was having a bunch of feedback on my end. I don't know what I did, but it corrected itself, I guess.
Perfect.
So we install 2,500 to 4,000 acres a year at Diversity D. I farmed for 25 years, so I've actually farmed and actually have walked in the same shoes as my customers, and I feel like that gives us a little bit of an advantage to where we know about the growing process and about what Ami talked about earlier in the presentation. We've actually experienced that and done it ourselves, as well as installed the drip, and so I think it gives us a little bit of a better deal. It makes us understand where the farmer is and what's coming on and doing. We sell pivots as well. We've had some, sometimes you have some economic turn downs, and we went to selling pivots in 2009. We felt like that it gave us an advantage to meet more growers and maybe provide more solutions for those growers and give us a better understanding of what our growers' needs were. Anyway, just a little bit of a brief overview of what we're going to talk about. We're going to talk about installation and maintenance today. We're going to do a few do's and don'ts. We'll talk a little bit about dripper line, main line, some kinking of risers, just general maintenance, flushing, and your shutdown at the end of the season. I've already talked about how we've had 25 years of farming background. We've got 25 full-time employees at Diversity D. Our first installation was in the high plains here where we're located, was in 83 and 84. Diversity D's first installation was in 1994. We had a customer that we installed 80 acres for. In West Texas, our water is declining. A quarter section that when we first started out irrigating, they may have had 500 to 600 gallons a minute. There's some areas that it's reduced down to 200 gallons a minute now. Our aquifer has declined. Our drip irrigation is our most efficient way to supply that water. With our other irrigation practices, we save about 25%, which is evaporative losses that the plant's able to see and utilize using drip irrigation compared to other irrigation practices. Today, there's about 600,000 acres in drip irrigation for cotton, corn, soybeans, sunflowers, and grain sorghum. We've been doing a long time, and there's lots of acres that's been converted over, and we've seen that transition. We've went through that transition and seen it, and saw our customers become more successful with the drip irrigation. Typical application here on the high plains now, here in Texas, is about a 0.15 to 0.2 inches per day. It's kind of, sometimes we deficit irrigate is what we call it. Some people think that we don't have enough water to grow a crop, but what we're able to do is, as Ami talked a little bit about it, is we store water in that soil profile. We're putting water on during the time that the plant's not utilizing it, and we create a water pot, if you will, and we store that water in the root zone until it's necessary, until it's needed, so that when we hit those times of ET that the water is, our requirements may be a 0.33 inches per day when it's full load and trying to fill that crop out, and we may be only able to supply a 0.2 inches that day, and we pull that extra from that soil profile. We're going to talk a little bit about installation here. The picture that you see here on the screen now, that's a tractor with one of our crews installing here. We're actually installing drip tape. It's about 11 inches deep. There's 6 rows that we're plowing in at one time, and the rows are just right at a meter apart. They're 40 inches is what we're doing here. This is you know, in the installation process, you think, well, the first thing to do is plow tape in, but that's not really where it starts. Where it starts is with the design. We start with our design, and we go out and measure the field. We get a topographical map, and we come up with a design. And in that design process, we're considering the general farm practices that that particular farmer in that particular area demonstrate, what they use and what they do on each farm. You'll see a little bit of difference there as it goes. And here's a typical design of what you see of how we've designed it. If you'll notice that over here on the far left, you'll see 4 circles, 4 blue circles in a group of 4 down here. Those are actually flush lines on the lower end of the field. The red is the supply lines up on the right hand side of the screen, and we'll typically group our valves together, and we'll operate multiple valves during the irrigation cycle. One of the next things that we do is we've got an overall master plan. We've got a plan how we're going to do it. We want to look at in that design, we want to make sure that we're looking at even the expansion that might happen on that farm. We want to take in consideration the whole farm. If there's any possibility at all that they'll expand those acres, we want to take that in consideration in our original master plan. That way, when you at the end of the day, as you put all this system in, you may not put it all in at one time. That we've taken in consideration, and we've got a system that looks like it was designed to be that way, and not a piecemeal project. So on this next slide here, it says a plow setup. We want to set that plow up in the beginning. We to set the plow up, what we end up doing is we look and we line up number 1 and number 3. and that is while we're standing at the back of the plow, we align the reel, number one, that's the reel at the very top, and we align that and centered over the shank, which is number 3, and we center that from left to right as we're standing at the back of the plow. And while standing on the side of the plow, we align that reel halfway from the core of the reel to the back edge of the reel. We center that directly over the top of the shank with that number 3 shank. And we let the roller assembly should be aligned, and that's number 2 is the roller assembly, and it should be lined directly over and centered directly over the tube so that no contact is made with the throat of the tube, that no contact is made. That way we don't have any contact with the dripper line coming in contact with the tube as it goes injected into the soil. You see on the left, you've got an injection plow here that we're plowing 8 rows in on this one. The injection is only about 9 inches deep. We're not real deep here. And you can see we have multiple people monitoring multiple rows as that injection is done. These injections, we recommend that each injection be done with a GPS tractor. That way you get uniform tape lateral spacing even on your guest row. It's good and straight, and then you have some repeatability where you can come back and plant directly over the top of those rows or whatever the case may be. The plow on the right is an injection plow that's going about 12 or 13 inches deep. It's a little deeper. It's plowing in 6 rows, not 8. It makes it a little, because you're going the deeper depth, it takes a bigger horsepower tractor, and typically the horsepower is not the problem, it's the traction, getting traction and making that happen. So we've dropped off a couple of shanks, and we try to match, when we're plowing in, we try to match a multiple of how many rows that they farm with. We try to take those farm practices into account when we're doing our design. This particular customer farms on a 24-row pattern, and we use 6 rows at a time to achieve that on that injection that we did there on the right. After the injection, after you do an injection, we go in here and we pack the dripper lines in. And what that does is by packing the dripper lines in, that pulls around and seals up the soil so that it stops the rodents from having access down to the dripper line. It also seals in the moisture that you have when you plow in that tape. And the third thing it does is it eliminates as many of the voids as we can around that dripper line, so that water will move back to the surface, so we can move that water back to the surface as quickly as possible. It's an essential part of the installation process. We recommend it on every project that we do. Once the drip line is injected, the trench is cut, and we consider the trench is cut considering the depth of the dripper line to make sure that we're to depth and we don't end up with a bunch of shallow tapes. In other words, we come out here when we decide where we're going to cut that trench, and we look and make sure that that dripper line is the depth that was desired, because it takes just a little bit of time. You have a little bit of waste on the end of those drip lines. It takes a little bit of time for that plow to get down in the ground and get down to depth. We go both directions. We plow down and plow back. And so when you're plowing down, it takes a second for the plow to get down to depth. And when you're plowing back, you'll be to depth. And so you've got to watch those and let that determine where your trench is going to be according to the end of the field there, in relation to the end of the field. Anyway, our wire tie connection here, this is a wire tie connection. When we cut that trench, we lay these pipes down in the ditch first. That's the first thing that we do. We lay our main lines and our sub mains and our flush lines, and it's very important that they sit on a firm bed in the trench. Any loose soil underneath these will result in the pipe settling, which is in the sub main causes that the sub main's a pipe that the dripper line connects to, and it causes the connection to pull out of that rubber grommet in the sub main. If you've got loose dirt underneath that pipe, when you get it connected and that weight of that soil gets on there, and then once that dirt gets wet, it can settle and pull that connection out, and that makes for a very disgruntled customer when that starts happening, because you've got to work down in the bottom of that trench and it's muddy and it's a mess and you don't want no part of it. So it's better to make sure that we have that on a good firm bed, that we don't have that issue coming up, making that happen. When we make the riser tube connection, that's a transition from the PVC pipe to the dripper line. We'll clean an area off above the dripper line, depending on how deep the dripper line is. We'll clean that area off and make a 6 to 8 inch shelf there. When we create that 6 to 8 inch shelf, the riser, which is a poly tube, is inserted inside the dripper line, and it goes past that dirt line 4 to 6 inches into the soil, and that way it supports that riser, and it doesn't allow that riser to kink in the backfill process. And so these pictures here are a picture of a good riser slipped inside. It slipped past that emitter, not the emitter, the dripper line. That tube is slipped past the dirt line there, and it goes on into the soil 4 to 6 inches inside that dripper line, and that supports that connection. You also want, when you're making these connections, you want to make sure that that the riser tubes are uniform. You can look down this trench and see how uniform they are. None of those riser tubes rise above the depth of the dripper line. That ensures that we don't have a bunch of shallow tapes there on the end of the field that can be damaged in our tillage practices. Here's another trench. This one's actually in a field where we went both directions, so we're center feeding and going to the left and to the right. This field here, you can also see that the risers are uniform and none of them rise above the depth of the tape. In the backfill process, the real key here is don't get in a hurry. You want to, the preferred method is to push soil from the field side and push it back into the trench. We push it in slow. We prefer to support, as you can see here in the picture, we're supporting that riser right there. We prefer to support each one of them as the soil enters the trench. If we don't do this, then we end up with some kinked risers the soil can get too heavy. You can have some clods that'll actually hit that riser and collapse it and create some issues there. One of the things, on things to do, if you were making a list of things to do, you want to have that master plan in place. You want to make sure that you have that master plan. You want to consider how the master plan fits with the existing and the future farm practices. You know, what's he doing now and what might he do in the future? And so you want to take some of those considerations into play and incorporate those into that master plan. Another thing is before we inject the dripper line, we want to make sure that we prepare that ground. And all my customers, we recommend to those guys that we do pre-ripping. We don't go and rip the field every which way they can. That's fine. But once that's done, we want to plow exactly where we're going to place that drip line in the same configuration that we're going to place that drip line. And we want to plow that to the depth that we're going to place that dripper line, maybe just an inch less. And so that when you do place the dripper line, you're reaching down and grabbing some fresh soil, some brand new soil that's fresh, and it doesn't create a hard pan there for you. You want to inspect your plow and make sure all your plow and other equipment. You want to make sure that the plow is set up correctly. If you don't have those guide rollers like we were looking at earlier, if you don't have those centered above that tube, then that can allow that dripper line to flop and come in contact with the throat of that tube and cause some drippers to be scored and cause some drip leaks that would have to be repaired after the initial startup. You want to monitor the depth of the injection throughout the field. When you're doing your initial setup, you can go in there and let's say you're putting your depth 10 inches or 12 inches, whatever your desired depth is to be. You can set that up. You want to make sure that you make that measurement at the speed that you're going to be traveling through the field. You don't want to be going slow and get your depth and then never check it again, because a lot of times when you speed up, it'll cause the plow to ride up out of the ground just a little bit. And so you want to be cautious of that. And you also want to check that depth periodically as you go through the field, because as we saw with Dr. Gibbs's stuff, the soil types can change throughout that field. And as you move through those different soil types, you may have to make adjustments to maintain the depth of your injection. You want to pack those drip lines into the field, seal that moisture back in so we don't lose any of that moisture, and try to eliminate those voids, and also seal that up so if you have any rodents in the field that we don't give them access to that dripper line. And the next thing, remember, you're the farmer. Don't forget how to farm. A lot of times when you move into a new technology like drip irrigation, it may not be new to the industry, but it may be new to you. And because it's new to you, this can make you be a little apprehensive, be a little reluctant to try new things, or you're afraid you're going to mess it up. You're afraid you're going to damage the tape or do something that you're not supposed to do. Remember, you've got a farm. You know how to farm. You know that farm more than anybody else, and you know what works on that farm and what doesn't. There may be some new things that we have to learn, and that's what a good distributor will do, is help you, walk you through that, and maybe share some of those experiences that he's already witnessed, he's already been associated with, and keep you from having to relearn some of those hard lessons. Things not to do is don't go fast. This is not a race. It's better to slow down and get that dripper line installed at the right depth, that you get a uniform injection done. Don't cut corners. We're going to look at the economic side of it, but we're also going to make sure that the integrity of that system, the design of that system is in place. And if you start cutting corners thinking you're going to save a little bit of money, a lot of times you can cut some corners that actually cost you money in the long run. And another thing is don't forget, you want to document your flows and your pressures of each valve after you get upon your initial startup. And so that you can, that's how you're going to gauge the health of that system, by being able to monitor those flows and pressures on each valve. You'll be able to maintain and see if you have any plugging issues, or if we have any, maybe we've lost some flow. We can adjust those flows, and maybe we can adjust the pressures to accommodate for the flows if we've lost some of the volume of water that we started out with. Maybe we don't have that. Some of our fields that we deal with, when they start out, they may end up with starting out at 4 gallons a minute per acre, and by the end of the season they may be down to 3 gallons a minute per acre and lose 25% of the water throughout the season. So knowing your flows and pressures, this allows you to, we run multiple valves. We can shut one valve, increase the pressure on the remaining valves to the maximum pressure of that dripper line, and be able to utilize all of the water that's available, and continue and make the best crop, to produce the most amount of production with the amount of water that you have available. And then again, I'm telling you, it's really important. Do not forget you are the farmer. Don't forget how to farm, and don't forget to ask questions. There's no stupid questions. There's no silly questions. You can't ask enough questions. If you don't ask, you won't learn. And so be sure and ask all the questions. Sometimes we don't know what questions to ask.
Okay. Ross, thank you very, very much.
Absolutely.
And speaking about questions, maybe before you wrap up, we have 2 or 3 questions that maybe you can refer to.
Okay.
Okay, so one is, you can see, by the way, the questions, I think, on yourself, but I'll read them anyway so everyone will know what we're referring to. So the question from Leonardo: how many on average is the number of labor per hectares or acres is necessary to install this kind of soybean or corn or cotton projects, and the time to spend during the whole process?
I'm not familiar with hectares, but we typically have a crew of about 4 to 5 people, and we can do about, if we get started early and stay late, we can do about 80 acres in a week, in a 6-day week.
Okay, great, thanks. Question from, I guess, from Brazil, from Carlos. What is the usual length of the lateral lines?
There's multiple sizes of drip lines that we use. We use a 636, an 875, and a 990. And the 636, we can typically go about 600 to 700 feet, depending on the dripper flow and the spacing. With 875, we can typically go 13 to 1400 feet. And with the 990, we can typically go to 2600 feet.
Okay, guys, you will obviously, the ones who need it will have to do the conversion, right, to the metric system. But okay, great. And one last question from Desiree. What is the recommended tractor speed during drip pipe installation?
That was one of the deals that I talked about when I didn't talk about the speed, but I talked about don't go too fast. We go from 2.5 to 3.5 miles an hour is about the injection speed that I prefer. I've had a few go a little faster, maybe 4. But it typically, if something happens with the injection reel, that's when you tear things up. So about 3 3.5 miles an hour is where we typically going most of the time.
Which is about, I guess, 5 kilometers per hour. I hope I'm not mistaken. So, you know, a disclaimer, do the conversion on your own. Okay, so just for the audience, we have many more questions here, and we're doing our best to answer everything. We'll get to everything. We have your mails if required. We'll do some of the work even offline. Anyway, Ross, back to you for a wrap up.
Okay, this picture here is on the flush valve. That's what we do. We flush the ends of the lines out. You can see that water is very, very dirty. Somebody might ask, how often do you flush that out? That depends on what water source you're using and the quality of your water. And we drain all of those filtration and everything at the end of the season. Depending on, we run chlorine and acid sometimes through the drip system, and that's determined on what kind of bacteria or algae that you might have present. If you're using surface water, you're going to have more bacteria and more algae, so you're going to have to flush more often. You're going to have to run chlorine and acid more often than you would if you was using an irrigation well. That's good, clean water. If you had iron algae, you might have to do some more flushing and some more maintenance a little more often, a little quicker. Anyway, guys, I appreciate it. Thank you all very much for allowing me to speak to you. And if you got any questions, send me an email or whatnot, and I'll do my best to answer.
Okay, Ross, we want first to thank you very, very much. It was an amazing webinar, and thank you so much for sharing your great experience and spending this time in this webinar. It is it is highly appreciated. So that's about it, I think. Once again, regarding the question, we'll do our best to answer offline. Regarding people that asked during the webinar, yes, it was recorded and it will be available in, I think, I don't want to say a couple of days. It will take probably about 3 to 4 days. And you will be able to find it on our YouTube channel. Simply look for Nטפים Academy, okay? And you will find it there. You will find also additional webinars that were recorded in the past. And again, if you want to contact us, please go to nטפים.com. You can find there your local website, and you can find there the local representatives of Nטפים, and you can contact them directly. Once again, thank you everyone for joining us, and have a great rest of the week. Thanks again, Ross. Goodbye.
Bye.